4th, I guess. 4, 5, and 7 December. Your second eye is as of now. Okay. So let's see. Just 2 minutes. I'll start it. Start the presentation. Okay. Yeah. Yeah. Oh, my screen is visible for you all now. Okay. Yeah, my screen is visible, Akshay. If you can again just give a confirmation. My screen is visible. Yes, sir. Okay, fine. Thank you. Okay. Going back here, in the previous class, we just read about the SIG Pro mask. Okay. So now, today we'll start or we'll study the next signal, which is nothing but the SIG action. Now, what does this SIG action do? From the exam point of view, again, it is very important. See, because what happens in this unit is mostly you will get the questions like give the syntax and a small program for SIG Pro mask, SIG action, signal, and something like that, which we'll be discussing at the end of the chapter. I'll just tell you how the questions would be coming from this chapter now. Okay. So now we'll study about the next API or the next function, which is nothing but SIG action. So what does this SIG action function do? Okay. So this function allows us to examine or modify the actions associated with a particular signal. So for example, when a signal is executing, it has a specific, just a minute, just a minute. Okay, sorry. What does this function do? So whenever a signal is executing, what happens here is it has a specific action to be performed for it. So what does this SIG action API does is, so whenever a signal is being executed, whenever there is a system, it is an uninterrupted call and signal system has to do some task. So at that time, SIG action system call can be used to test it, what action that signal is performing, whether it wants to terminate, whether you want to suspend, whether it wants to kill process. So what action it is performing. That action it can examine or also it can modify also. Like it can try to change whatever the action it is supposed to be taken. And what does this function do is, now this function supersets the signal function from the earlier release of the Unix system. Now what it means is it acts as a third party authority, which says that whatever the previous Unix, what I can say is like system settings were there, it can be taking the place of that, like an authority, a person or an authority, which has the rights to change, modify, enable or disable the actions of a particular signal. This is found in the latest versions of Unix. Okay, when you go for the previous versions of Linux, you won't find this facility there. But in the recent versions of Unix, they have developed with an API called as SIG action, which means that it allows the user to modify the action. So for example, if a signal is there to interrupt a process, but you don't want to interrupt that process, what you can do is you can call in SIG action API, which tells that whenever a signal is being caught, its action is to interrupt a process. But this will stop that signal from interrupting. That can be done with the API known as SIG action API. Now SIG action API, again, it is found in the header file signal.h. It has 3 arguments. The first one is the signal number. Now this is nothing but the signal number whose action we are examining or modifying. So for example, signal number is nothing but SIG interrupt, SIG kill, SIG terminate, SIG hang up, all those signals. So whichever signals action you want to modify or you want to examine, that is nothing but the signal number you are performing. And the next one is the action pointer, this one. the SIG action pointer. What does the SIG action pointer do here is, if the pointer is not null, that means we are modifying the action. But if the pointer is null, then we can't modify the action. But if this signal action, if it is null, that is restrict action, what I have told here, if this is null, which means that we are not modifying the actions of that signal. Whatever the action the signal has, it has to perform the same. And this one, signal or restrict old action, the third argument, which means that if the pointer is not null, the system returns previous actions for the signal. So whatever the previous action was given to the signal, it returns that value. And if it is, this is not null, then we are modifying the action. See here, please make sure that if this value is not null, then we are modifying the action of the signal. For example, if there is a signal to terminate, sig term, assume that this is sig term, and if this is not null, that means that its action was to terminate, but still we are modifying its action to something new. That is nothing but the first one, restrict action. And third argument, which means that if the pointer is not null, the system returns previous action for the signal. So whatever the previous action was defined for that signal is returned by the third argument. And this returns 0 if executed properly, or -1 on error. So what exactly does this API do? The SIG API, SIG action API is a replacement of signal API. Signal API, we know that what happens, signal does it takes an action and it performs a command. Same thing in the latest versions of Unix, which I told you. This is just a replacement of signal API. So SIG action API is called by a process to set up a signal handling method for each signal you want to deal with. See, very important statement it is. So the SIG action API is called by a process. So there is a program which is executing. So in that program, there is a process which is running. So the SIG action API is called by a process. Is called by a process to set up a signal handling method for each signal you want to deal with. For example, in a process, there are 5-6 signals which are encountering. So it can call that SIG action to set up a signal handling method. What it means is, if one signal encounters, how should I tackle it? If the second signal encounters, how should I tackle it? Just like when you are running a game, see, this is very important in games over there. Just like Subway Surfer or something, the game which you execute, right? Which you played. So what happens? There is not only a single hurdle which comes in, the temple run or Subway Surfer, like that. Okay, so there is not a single hurdle which comes. You have n number of hurdles which are coming for it, right? Which are coming for it. So what happens over there? For each hurdle, how you can tackle it is nothing but the SIG action API. Please relate this with the real-time gaming concept now. As I said, Subway Surfer people have done it, I guess. You have played it also. Or maybe some games which you have played it, the running games or something. So every time when you run, a new hurdle comes into picture. Is nothing but a signal. So how to tackle that? Either you can jump from that, you can just go under beneath it, or you can just go to the side track or something like that, right track or left track. Please visualize that in Subway Surfer there are 3 tracks. You're running on a center track, so one hurdle comes. So how you can tackle that? Either you can jump above it, you can go below it, you can go to the left, you can go to the right. See, this is nothing but the SIG action API. It is more useful in the gaming concepts. Okay, nobody asked me in the initial where this is used, but this is more useful in the gaming concept. So it is called by a process to set up signal handling. Signal handling means how should I handle that? Now, for the example, there is a box in front of me. How should I handle it? I can jump above it, I can go to the left, or I can go to the right. Simply, if there is some other hurdle, how I can deal with it. So all this is taken care by SIG action API. So SIG action API returns the previous signal handling method for a given signal. So if it is not null, it writes the previous signal handling. So what was the previous handling method used? The same is taken care by that. So this is what is SIG action API. If it is asked in the exams, what is SIG action API? You should explain this, give the syntax, and this is what the structure which I was talking. SIG action structure. This. So what does the SIG action structure holds? It has 3 members in it. The first one is signal handler. It is nothing but the address of the signal handler, or either it is sig ignore or sig default. So this first argument says that whether it is the handler of the signal, what either it can be a user defined handler, or it can perform its ignore, or it can do its default action. So all these three, it can be taken as the first member. And the second member is additional signals to be blocked, which means that if a process is executing, it has more than one signals to be blocked. Okay, so in that case, rather than blocking a signal, which all additional signals also can be masked, is nothing but sig set mask, which says that apart from the original signal, which all additional signals can be blocked. And the third one is signal options. Now, signal options is nothing but the various flags which can be used when you are executing a SIG action API. So the first flag, it can be SA underscore restart. If the value is SA underscore restart, system calls interrupted by this signals are automatically restarted. System calls interrupted by this signal. If this value is SA underscore restart, and whatever the system calls are interrupted by the signals which is called are automatically restarted. On the similar lines, if SA underscore flag value is SA underscore NOCLD stop, which means that if the signal number is sick child, it do not generate this signal when a child process stops. This is what I'm talking here. If this is the signal number, if it is a sick child, if this is a sick child, and this argument is SA underscore no child stop, CLD stop is child stop, then it do not generate this signal when a child process stops. So whenever a child process stops, the signal which you want to throw it will never be generated. And the third value for SA underscore flag is SA underscore sig info. Now what does this do is, this option provides additional information of a signal handler, like if a signal is being performed, what are the additional informations are available that can be taken care by the sig action function. Okay. Again, same thing, the SA handler, the signal handler I'm talking. The SA handler field can be set to either signal ignore, default, or a user defined handler function, which I told previously. So SA underscore mask, this is what I'm talking here. The same thing is explained here. SA underscore handler can be either a user defined handler, ignore, or default. Sig set mask is a field that specifies additional signals that process wishes to block when it is handling sig no signal. So once a signal is being executed, apart from that, which are the various signals it wants to block it, that can be specified by SA underscore mask. The signal number argument designates which signal handling action is defined in the action argument. And the previous signal handling method for the signal will be written via old action argument if it is not null. That is what I told. And if the action is a null pointer, the calling process exits the signal handling method for signal which will be unchanged. So this is how it is explained here in this simple program. Now I've just defined a system call, call me, in which I'm passing the signal number. So what does the cout do is, it will catch signal, a message, and the signal number will be displayed here. So in the main, what I've done, I've defined sig mask. So this sig set mask is initially, and again sig action, the action and the old action, the structures, action and old action. So initially what I'll do is, I'll check whether any signals are there. If it is empty set, that is sig empty sets will check whether any signals are imposed on the process. This will check. If not, then you will call sig add set. Now sig add set will add a signal. So what are you doing? For that signal mask, you are adding sig termination signal. And if it is equal to -1, or if the sig pro mask is nothing but again to get the details of the signal. If it is sig set mask and the signal which you have called is 0 -1, then you can throw an error that is set signal mask. That means you're trying to add a signal but which is not being added for you if it is -1. But if it is not, then it will call sig empty set mask. So now initially it was nothing. So now what you're doing for the member function, you are assigning a signal mask. After that, you are adding signal sig add set. So for that action you are adding sig segv signal. Then what you do is, again the next member handler you are calling call me. Now here for the handler there are three options. Either you can use a user defined function, you can use a default function, or you can use an ignore function. So here what I'm doing is I'm calling the handler, that is call me. So once it calls me, it goes to this signal handler and it catches the signal which is being imposed. Initially there was no signal imposed, then you have added the signal. So which signal was added, that action is performed here, and after that you are calling the sig action. Now what does sig action do? For sig action you are passing the first argument as sig interrupt, which means that the signal sig interrupt its action and old action. If it is -1, it shows an error. That is, if it is a null pointer. If not, wait for signal interruption and return the value. Now see how this works here. Okay, I have just written the code also for you here. Same code which I have just told now. The same code is written here. So how would be this output be running here? Now see, I'm running this program. Okay, here. Now it is going in infinite loop. See here, this program is in infinite loop because whatever the signals are set initially are removed. Just come here. From the main, sig empty set is there. This is never executed, no error. So now it is empty. So what is happening here is, it is in infinite loop only because it will be terminated only when a signal handler is performed. It goes in infinite loop. So what is happening here is, this process is going in infinite loop. So the minute I press Control C or Control Z, I am calling a signal handler. That is handler. So once this handler is called, the control goes here, whichever the signal I'm passing, and that signal number is displayed for me. Let's see how whether this works. So I'll just press Control C. See, cat signal 2. Now what it means here is, whenever a process is running, you can examine its signal action or you can modify its action. Now its default was to interrupt, but you modified it by calling call me function, call me handler. Now this can be only done with the help of sig action API. So please remember, sig action API is used to examine or modify the existing handling functions of the signal. It can modify. Just a minute. That is what it does about sig action function. So if it is asked in the exams, if you look at the textbook over there, it has very big program we have given. So this I just tried my best to make it simple one. So what is here? Sorry. Sig action. Sig action is a function which allows us to examine or modify the action of a particular signal. This acts as a third party which has the control of the signal. This is very important. Supersedes means it takes the authority from the earlier release of the Unix system. And what it does, it's nothing but same to what the signal API does, but this is found only in the latest versions of Unix. Okay, if you try this code in the Red Hat or something, this may not work for you because it is only available on the latest versions of Unix. Okay, so this was about sig action. So this is what it does now. In this program, the process signal mask is set to sig term. The process defines signal handler and all whatever I told, it is set here. Next is the sig child signal and the wait PID API. Now this is very important over there. Usually they ask in the exams, explain the sig child signal and the wait PID API. Now what is this all about? So we all know now there is a parent process and there is a child process. So whenever a parent creates a child process by the system called fork, so what happens? In a parent there is a child process which is running. So when a child terminates or when a child stops by itself, what will the kernel do to tell the parent? Okay, you're getting it. Now there is a parent who is being executing. Now parent creates a child process by the system called fork. So once a child process is created, so once a child process okay, that means whenever parent creates a child process, what happens here is now child is executing. Now as I told again, the context switching. So when a parent is executing, it may so happen that child may also execute. So what happens here is parent and child both are executing. So meanwhile, what happens if a child terminates by itself or child stops? What will the current parent do, or how will the parent get intimated? So in that case, there is a signal known as sig child signal. So whenever a child process terminates or stops, terminates by itself or stops by some signals, what will the kernel do? The kernel will generate a sig child signal. It is not child, okay? It is sig chld signal to its parent process, because parent should also be knowing what is happening with the child, or it can't wait for a longer time till the child is executing. Something like if a child process goes in infinite loop, the parent can't wait for a longer time, right? In that case, it has to terminate the child process, or it may so happen that child is executing. After some amount of time, the child terminates or child stops. Now parent should also be intimated because parent is in sleep mode. So what happens here is, so in both the scenarios, if a child process terminates by itself or it is stopped by some other process, the kernel will generate a sig chld signal to its parent process, saying that the child process has terminated or stopped. So depending upon how the parent set up the handling for the sig child signal, different events may occur. Now, when a child stops, now child has to do something, but still some abruptly child stopped, or maybe the context switching took place for which the child has stopped. So once parent gets a signal from the kernel, that is sig child signal, now parent the parent process has different events it can occur. The first one is the parent can accept the default action of the sig child process. That means there was a parent process, it created a child process, child stopped or child terminated by itself somehow. Then kernel intimated the parent, saying that the child process has stopped or terminated. So depending upon the events, the parent can take a decision. The first is the parent can accept the default action of the sig child signal. So a sig child signal came to the parent. Now one thing it may happen that it may accept the default action. Now what is the default action? Sig child does not terminate the parent process. Parent process will be awakened. API will return the child exit status and process ID to the parent. Kernel will clear up the process table slot allocated to the child process. Parent process can call wait PID repeatedly to wait for each child is created. So what it means is, whenever a child terminates, the parent can accept, first thing is default action of the sick child. So what are the default action? It will first and the foremost thing is, it will not terminate the parent process. That is, it terminates only the child process, and parent process will be running only. Even if the child terminates, parent is not forced to terminate, it can continue its execution. And once the child terminates, its process ID or its exit status is told to the parent process, and that once the process terminates, its value is taken out from the process table. Remember, we studied Unix kernel support for processes. Each entry is made in the process table. So once a process terminates, its entry is also removed from the process table, and parent can keep on waiting for its each child whenever the child is created. So this is the first thing. So whenever a child terminates, parent is intimated the child is terminated by the kernel. So once this is intimated by the kernel to the parent process, parent has various actions to do. The first action is it can accept the default action of the sick child signal. Second one, parent can ignore the sick child signal. So first one was to accept the default. Second one was to ignore the sick child signal. So what does it do is here now? Now sick child signal will be discarded. That means now parent is executing and somehow child has terminated. So once child has terminated, parent will not wait for the child to terminate, and parent will not be disturbed even if the executing system call is executing. That means sick child signal will be discarded. Now child wants to tell the parent that I am been terminated, but if the parent calls the ignore system call, which tells that the sick child termination will be discarded, it will not be known to the parent, and parent will not be disturbed even if it is executing the wait PID system call. That means parent is waiting and child terminates somehow. But still, if it calls the ignore system call, the child termination will not be told to the parent, or it will not be disturbed also. Parent also keep on waiting. In the previous thing, how it happened, if the child terminates, parent become awake and it takes the control. But in here, when the parent ignores it, what happens here is the parent will not be disturbed. It will keep on waiting only. Even if the child terminates, no issues for it. It keeps on waiting only. The parent can call wait PID API, and the API will suspend the parent until as its child process has terminated. So it keeps on waiting for the process until the parent and all its child process have been terminated. And obviously, child process table slots will be cleared up by the kernel, and API will return -1 to the parent process. Now, all this task will happen. All this task will happen when parent ignores the sick child signal. First one was, if the sick child signal is given, it can accept the default action, which does this. If not, it can ignore it. Or the third one is, if the child has terminated, now process can catch the sick child signal. Now catch means take that signal and you can perform whatever action a parent wants to do it. That is nothing but the user defined function I have said. Something like in signals only. So what does happen here is, the signal handler functions will be called in the parent process whenever a child process terminates. That means now the parent process has defined a signal or a user defined function that tells that whenever a child process is terminated, the signal is generated in the parent process to intimate parent that one of its child is terminated. See, because in parent process there is not a single child. In a parent process, there may be more than there can be more than one. Okay, so this is how exactly it works over there. And if the signal arrives while the parent process is executing, if the signal arrives when the parent process is executing the wait PID system call, the wait PID may be restarted to collect the child exit status and clears its process table slot. That means the parent has set a handler saying that whenever a child terminates, the signal will automatically pop up, just like your notifications. See, process catches is just like a notification. So on your mobile, you keep on getting the notifications as and when something comes in WhatsApp or Insta or something like that, right? So here you can either see in the shutter box only, or you can open that and see in that app itself, right? Same thing happens here also. If the signal child arrives when the parent process is executing the wait PID system call, the wait PID may restarted to collect the child exit status. So it means the parent is executing and child terminated. So again the parent process will be restarted. The waiting of the parent will be restarted to collect child exit status. Or depending upon the parent setup, the API may be aborted and child process table slot is not freed from the system. So it may so happen that if the child process is terminated, if the parent has set up its own setup, the API may also abort the child process, parent as well as the child process, and the memory is kept buffered only and it is never freed over there. So this is what happens when a child terminates in a parent process. Please remember, parent is still executing and child terminates, then only all this process will happen. If the parent has already terminated, then the child becomes a zombie process, which you have one of the lab term work also later on we'll study. So if the parent is executing and child terminates, then parent can do either of these three tasks. It can accept the default action, or it can ignore the sick child signal, or it can call its own user defined function. So either of these three, it can be done by the parent process. So this is what happens when a parent is still executing and child has terminated. Please remember this. But if in the parent and child is executing, and if the parent terminates by itself, then there is a problem. Then it is called as a zombie process. But if parent is still executing and child terminates, the parent has different actions to be done, except the default action: ignore the sick child signal or process catches. Now, how can we relate this in real time? Take a simple example now. Assume now a class is going on in a classroom. We have started exactly the class at 9 a.m. The class is started. Faculty is there. Students are still entering. Okay. So first is the default action is what? My default action is, if the student knocks the door, I have to stop it, stop my presentation or stop my class, wait till the students get in the class and sits on the desk. Once they're settled, then again I'll continue. Yeah, see, please relate this. Seek action and wait PID API. How it is related in real time also now. If a class is going on and somebody enters at 9:1 or 9:2, so obviously it is very sure that I'll stop it for some time. They say, excuse me, sir. They enter the class. They sit on a desk. I have to keep waiting till they settle. Then I'll continue my class. That is a default action. Similarly, the second action is ignore. Even if you are entering, I'm not bothered about it. I continue my teaching itself. That means you all are entering. The child process, they are like terminated and they're entering. But parent will ignore them and do whatever it is doing. Third one is process catches the signal. Now here, once the students enter, now a faculty can take either of the action. Can tell the student saying that you're already late, you can leave the class. You entered, you sit on the first bench, or something like that. That is what I'm talking about in the signals also. It has three ways to do it: parent as well as child. Now the same scenario, if faculty is not there in the classroom, you can do any of the things over there. You can get in the class, you can get out the class, whatever it is. But if the faculty is there, then this actions will be performed. But if faculty is not there, you are free to do anything. That is called as a zombie process. A process whose parent has expired is called as a zombie process. So this is with signal, sick child, and the wait PID API. Okay. I'll stop it for the day now here, because this again I require some time to explain this. Sig set jump and sig long jump. Okay. So in the today's class, we have just studied about what is SIG action API. SIG action API is used to determine or examine the signal handling actions. Okay. After that, we studied about signal, SIG child, and wait PID API. That is what a child process can be done. Okay. So we'll stop it for the day here. Just please take this quiz and answer me. Okay. And we'll stop it. So next hour is Girish sir will be taking the class for you. Okay. Yes. Thank you. Have a nice day. Okay. I'll stop it.